number one, they give you the graph. This blue graph is the graph of x plus 3 plus k, and then they want you to graph just x plus 3. So x plus 3, the m is the slope, and that's 1, so 1 over 1. And then the b is 3, so it's going to start at 3. And it's going to go up 1 over 1, up 1 over 1, up 1 over 1. So it's parallel to the line in blue. Okay, now they want you to compare these two functions, and if this x plus 3 were translated into the blue line, it looks like they just shifted it down 2 units vertically, and that's what k does. K shifts it up or down. So the blue line has been shifted down. They want you to figure out if you can find the value of k. So the blue line was shifted down twice, so k is going to be a -2. So if you take x plus 3, and if you want to shift it down twice, you just add a -2 at the very end, and that shifts it down twice. So k equals a -2. Okay, number 2. They have graphed y equals x squared, and then they want to know what if you graph x minus 4 squared. So your vertex form and kind of your translation form is the same for all families of functions. So we just did a k. If you plus k at the very end, that moves it up and down. If you add or subtract inside the parentheses, that moves it left and right. And then the dilation, kind of the slope out here, is if you times it by something, that changes the steepness. So the model has to have a minus in it. And so this x minus 4 is really just x minus, and that's all part of the model. So the 4 is what you're looking at. And since it's really like a positive 4, we're going to move it 4 units to the right. So you're going to take this quadratic and you're going to translate it 4 units to the right. So it's going to be just like that. Number 3. So you got a bank of numbers to choose from, and you need to place one number in each box so that the top will equal the bottom. So they want you to raise something to a power, but they want it to be a fraction, a rational number. So hopefully you remember that like 9 to the 1/2, if you have fractions for exponents, that's the exact same thing. If you morph it to a radical, that's the exact same thing as the square root of 9, and the square root of 9 is 3. So if we do 9 here and a 2 there, that's 9 to the 1/2. Then you can drag and drop a 3 into that box, and those two expressions should be equal. Or you could do 4 to the 1/2, and 4 to the 1/2 would equal a 2. So there's 2 answers that you could choose from, either 9 to the 1/2 or 4 to the 1/2. But that is it. So there's kind of more than one right answer. Okay, number 4. They've got a function graphed here, and this function, the denominator, if you factor it, is going to be easier to work with. So if you factor x squared minus 2x minus 15, that's going to factor to x minus 5 and x plus 3. So now if you look at it like this, so it's a kind of a mess. It's a big old fraction, and the number 1 rule is you can never ever ever divide by 0. So you can never have 0 on the bottom. So the two numbers that you need to be aware of, x can never ever equal a 5, and x can never equal a -3. Because if x were to equal either of these two, then you'd have a 0 on the bottom, and then that whole thing would be impossible. So this asymptote right here, if you're looking at a graph, asymptotes are lines that the graphs can never be. So if x can never be 5, over here on this x-axis, here's 5 right here. Okay, x can never be 5. So you've got a vertical line going all the way through 5. So this graph is never going to touch 5. It's going to get closer and closer to 5, but it's never going to touch 5. And it's never going to touch a negative 3. So on the x at negative 3, there's negative 3. You're going to have a line here. And these red lines are never going to touch this blue line. They're going to get closer and closer to it, but they're never going to touch it. Okay, number 5. You got two tables that describe different functions. One of them is geometric and one of them is arithmetic. Arithmetic grows by addition and geometric grows by multiplication. So the arithmetic one is this guy right here, because that's adding 3 every time. So g of x is going to be arithmetic, and then this one is times him by 2 every time, is doubling, times 2 times 2 times 2. So let's see, f of x is this guy, so that's geometric, and g of x is arithmetic. Grows faster. F of x grows faster than g of x. Also, I guess you just drag and drop these into the right spots. Six. Evaluate this expression. This expression looks like it has a couple imaginaries. This is a multiplication, so you're going to distribute the 3 to the 2. That's going to be a 6. The 3 to the negative 7i is going to be a negative 21i, and then plus 4i, and these are your like terms. So combine your like terms, and you're going to have 6 reals, and you're going to have a negative 17 imaginaries. So they want the 6 here, the minus 17 imaginaries there. You do not need to use all the boxes. Okay, 7. So you kind of got 3 rows, and you need to drag and drop from the bank to make these equal. Okay, the square root of 16, I know the square root of 16, square root of 16 is just 4. So that has to equal 4 to the 1. And now, I wonder if you can use numbers more than once. That's something I don't know. So, let's see if we can do this one. 64, I know if you do like the square root of 64, the square root of 64 is 8, and 2 cubed is 8. So a 2 there and a 3 there would make that true. The 4th root of 27. Okay, now 27 is going to break down to a 9 and a 3, and 9 is going to break to a 3 and a 3. So that's going to break down to the 4th root of 3 cubed. Okay, now if I morph this radical into an exponent, the base is 3, and it's going to be 3 to the 3/4. So I'm going to put a 3 there and a 4 there. 3 to the 3/4. Alright, number 8. So function f is this fraction right here. They want you to find f of 1. So let's take 1 and let's replace it, substitute it in for these x's. So it's going to be 1 squared plus 1 divided by 1. So that's going to be 2 divided by 1. So f of 1 will give you a 2. And if you plug in a negative 2, a negative 2 squared plus 1 divided by a negative 2. So negative 2 squared is a negative 2 times a negative 2. That's 4. 4 plus 1 is 5. So on top you got 5. On bottom you got negative 2. So that's going to be this guy, negative 5 halves, right there. Ooh, okay, you've got select all expressions that are the same as 4 to the 1 half. So I guess we go through them one at a time. 4 to the 1 half. Oh no, that's 4 to the 3 halves. Okay, this first one, I've got an exponent raised to another level, so I'm going to times the exponent. I'm going to times 2 by 1/3. So when you're timesing fractions, times the tops, times the bottoms, that's going to be to the 2/3. So that one is not. Same thing, times the exponents, 1/2 times 3. Make 3 a fraction, that's 3 halves. So that one works. And if I morph this, it's going to be 4. The 2 is my numerator, and the 3 is my denominator. That one is not. Okay, this one, the cube root of 4 squared, that one, oh man, that's a good one. The cube root of 4 squared. The cube root of 4 squared, is that the same as this? 4 to the 2/3. So does it matter if the exponent is outside or if it's inside? So the cube root of 4 squared is the same thing as the cube root of 4 times the cube root of 4. Yeah, that is going to be the same. So if you're timesing them, that's going to be the same as the cube root of 4 squared. So that will be 4 to the 2/3. So that's no good. Okay, 8. If you break 8 down, 8, if you try and express it as a 4, 8 is a 4 times a 2. So, no, that's not going to be 8. We can kill 8. This guy right here, 4 to the 3, the index, if there's not one, it's a square root, so it's going to be 4 to the 3 halves. That one's good. Times your exponents, 3 times 1/2, that's going to be 3 halves. That's good. And this is the same as this. The index is 2. Doesn't really matter if the exponent's on the outside or the inside, because that's going to be the same. So that's 4 to the 3 halves. That one's good. And then times 1/3 by 2. That's going to be 4 to the 2/3. So that one is no good. Okay, you've got the cube root of x squared. Place a positive or negative in the circle and then a digit in the boxes. So if you morph this, that is going to be x to the 2/3. So I think we put the positive in there and the 2/3 there. Okay, this one was tough. So they got a model here. Susan takes M minutes to finish a puzzle. It takes Jocelyn 12 minutes. More than Susan. Working together, they can finish it in 8 minutes. So if we do 8 minutes divided by Susan's portion and 8 minutes divided by Jocelyn's portion, and if you add those together, that's going to make one whole. So place one number in each box to show the amount of time it takes Susan to finish the puzzle. So Susan is M, so we want to solve for M. We want to get M all by itself. So if you've got a fraction and your variable is in the bottom, so I want to solve for M, I want to ditch everything else. I need to multiply this term, and this term, all three terms by the same quantity, and I'm going to multiply them by the common denominator. I'm going to multiply this guy by m times m plus 12. I'm going to multiply this guy by m times m plus 12, and I'm going to multiply this by m times m plus 12. Now if I do that, it's going to get rid of these two fractions, because I want to get rid of all the fractions. So now put this over 1, put this over 1. This m is going to cancel that m, and so you're going to have 8 times m and 8 times 12, and that's going to be 96. This m plus 12 is going to cancel this m plus 12, and so you're just going to have 8m, and then this 1 times m plus 12 is just going to be m squared plus 12. So now it's a quadratic. Now if I get all my terms on the same side, so I'm going to add these, and that's going to be 96 plus 16m equals m squared plus 12. So I'm going to move these guys over, and we are going to have, do we have m squared minus 16m plus 84, no, minus 84. I want a minus 84. Alright, so I think I messed up. So when I times the m to the m, that gave me my m squared, but the m times the 12 is not 12. It should be 12m. So that's going to change things a little bit. When I bring the minus 16m's over, this is going to be minus 16m. These are 12m, so these are going to play together, and it's going to give me m squared minus 4m minus 96. Okay, now that's going to equal 0, because on the other side I got nothing. So if I can factor this, if I can find something that times this and gives me a negative 96, adds and gives me a negative 4, then we want to factor it and rewrite it as the product of these two quantities. So it's going to be m and m. What times this and gives you 96, adds and gives you 4. It is going to be an 8 and a 12, and the 12's got to be negative, because when I add them, they add and give me a negative 4. So it's going to be plus 8 and a minus 12. So m has got to be a negative 8 or a positive 12. And m is how long it takes her to finish a puzzle. So negative's not going to make sense in this story, but the 12 will. So it's going to take Susan 12 minutes to finish it by herself, and then it would take Jocelyn 24 minutes, because it's going to take her 12 minutes longer. Number 12, an exponential equation is 3 times e to the 4x equals 9. So logs. In your logs, this is going to be a logarithm. We're going to use a log to solve it. So there's two logs you need to be familiar with. The common log, which is log in base 10. If you ever come across a log in base 10, it's so commonly used that we don't even need to write the subscript of 10. You can just write log. And then the other one is the log in base e, and that is the natural log. And the natural log is just going to be abbreviated as ln, and that's what this is right here. This ln, it's a logarithm, and it's a logarithm in base e, and e is a number, just like pi is a number. So we want to solve for x. We want to get x all by itself, and x is in an exponent. So to solve for x, we're going to use a logarithm. first, let's undo the times by 3. Let's ditch this 3. Let's divide this side by 3, and let's divide this side by 3. So now we've got e to the 4x is equal to 3. And now if we want to morph this to a logarithm, it's going to be the log. E is going to be the base, and you're going to take the log of 3. And that is going to give you 4x. So now if you want x by itself, we just got to ditch the 4. So let's divide this side by 4, and let's divide this side by 4. So log base e of 3, that's the same thing as ln of 3, the natural log of 3. So I'm going to put a 3 here, and if you're going to divide by 4, that's the same thing as multiplying by 1/4. So I'm going to put 1/4 here. Because times by a 4th, dividing by a 4 is the same thing. 13. Two polynomials are shown. Find the product of these two. So that's just a multiplication problem. Take x squared plus x minus 3 and times it by 3x plus 8. So distribute, and that's going to be 3x cubed. X squared times 8 is going to be 8x squared. X times 3x, that's going to be 3x squared. X times 8 is going to be 8x. A negative 3 times 3x is a negative 9x. And a negative 3 times 8 is a negative 24. And add up all your like terms, so you're going to have 3 cubes plus 11 squares minus 1x minus 24. Okay, 14. Okay, you got 3 parts. You need to find the function, tell me where it's positive, and tell me where it's negative. So let's do B and C first. The intervals where this function is positive, the function is going to be positive anywhere that it spits out a positive output. So if we look at, if you look at this function right here, so if we've got negative 2, 1, 0, 1, and 2, and this is a negative 4, this is a negative 2, this is 0, and then this is 2, and let's say this is 4. Okay, it's gonna spit out a positive right here, because these answers are positive, and it's negative right here when these answers are negative. So when your answers are positive, that's when it's positive. When your answers are negative, so you're looking at the y's. Okay, the y is this number line going up and down. So here is 0 on the y. So anything above 0 is positive, and anything below 0 is negative. So it's going to be positive from here to here. So on the interval, so let's look on the x-axis. As soon as x hits 0, 1, 2, and 3, anywhere from 0 to 3, it's positive. So when x is smaller than 3 but bigger than 0, and then right here it's negative, 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 but then up here it's positive, 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 and x is anything bigger than 5. So that's an interval when it's going to be positive. Okay, it's going to be negative right here, and right here, and here. So it's negative when it's below 0. So anytime x is less than 0, it's going to be negative, and then anytime x is between 3 and 5, as long as it's bigger than 3 and smaller than 5, that's when it's negative. Okay, now to complete the equation, it's a cubic. We know it's a cubic because there's 3 zeros. There it crosses once right there, there's a 0, there's a 0, there's a 0, so it's going to be a cubic. Now, this cubic, this is kind of the A, and that's the hardest part to find, but they're giving it to us for free. The a is 1. That's kind of the dilation. That's like the slope. So we don't need to worry about the slope. So all we need to worry about is filling the rest of this cubic out. And if they give us the zeros, we can take and work backwards from the zeros. So if your zeros are 0, it's going to be x. And this 0 is a 3, that's going to be x minus 3. And this 0 is a 5, so it's going to be x minus 5. So this polynomial will give you these 3 zeros, because when I plug in a 3, 3 minus 3 is a 0. When I plug in a 5, 5 minus 5 is a 0. When I plug in 0, 0 creates a 0. So I'm going to times these two first. X times x is x squared minus 5x minus 3x plus 15. So that's going to be x squared minus 8x plus 15. And now if I just times x to all of that, it's going to create x cubed minus 8x squared plus 15x. So x cubed minus 8x squared plus 15x. Find the zeros of this polynomial. Okay, you've got 4 terms. If you've got 4 terms, the trick is to group them. Uh-oh. Okay, when we group them, we're going to group these two together. And then we're going to group these two together, a negative 3x plus 6. Okay, these two, I'm going to divide them both by x squared. Divide that by x squared, divide that by x squared. So if you rewrite it as a multiplication problem, if you factor this, it's going to be x squared times x minus 2. And if you factor this, divide them both by a negative 3. If I divide them by a negative 3, that will create a negative divided by a negative. That's a positive x, because that's what I want. I want a positive x and I want a minus 2. 6 divided by a negative 3 is a minus 2. And now, let's divide both these by x minus 2. So one of your answers is going to be x minus 2. The other one is going to be x squared minus 3. So the zeros, I know because it's a cubic that there's going to be 3 zeros. And one of them is 2, because if I put a 2 in here, 2 minus 2 is 0. And the other one is what will make this a 0. So whatever I square, it's got to be 3, because 3 take away 3 is 0. So x squared minus 3 is 0. Plus 3 plus 3 x squared equals 3 square root. So it's going to be plus or minus square root of 3. So your other 0 is going to be a square root of 3, and your third 0 is going to be a minus square root of 3. So there are your 3 zeros. Because the square root of 3 squared is 3. So 3 minus 3 is 0. Okay, this one's kind of nasty. So expand it. If you got 2x plus y to the 4th, that is 2x plus y times 2x plus y times 2x plus y times 2x plus y. So distributive property, that's going to be 4x squared plus 2xy plus 2xy plus y squared. Now combine these like terms. So it's going to be 4x squared plus 4xy plus y squared. And I'm just going to times, I know that this times this is going to be the same. So it's going to be 4x squared plus 4xy plus y squared. So now, if I times this to this, That's going to be 16x to the fourth. If I times this to this, that's going to be 16x cubed y. And if I times this to this, that's going to be 4x squared y squared. Now if I times this to this, that's going to be 16x cubed y. So I'm going to put that under here, because they're like terms. 4xy times 4xy is going to be 16x squared y squared. And then 4xy times y squared is going to be 4xy cubed. And then the last one, a y squared times a 4x squared is a 4x squared y squared. A y squared times a 4xy is going to be 4xy cubed. A y squared times a y squared is going to be a y to the fourth. So if I add up all my like terms, I'm going to have a total of 16x to the fourth. Plus how many x cubes y? 16 and 16, that's going to be 32. Plus the 24x squared y squareds, and that gives me 24, so I'm good. They want to know how many xy cubes. I got 4 and 4, so that should be 8.